Hello, and welcome to a video about the scientific models of the atom. New experimental evidence constantly leads to scientific ideas changing. The model of the atom that we now accept has developed over time and may still change in the future as new evidence emerges. In the exam, you may need to describe the key changes in our ideas about atoms, and this is what I'm going to talk about in this video. Originally, when Greek philosophers were the scientists of the time, atoms were thought to be tiny spheres that couldn't be divided. The word itself, atom, comes from the Greek atomos, meaning indivisible. Later, in the early 1900s, the discovery of the electron led to a new model called the plum pudding model. Instead of being an indivisible sphere, the atom was now thought to be a ball of positive charge with negative electrons embedded in it. You might not see the link between atoms and plum puddings, but if you think of a Christmas pudding, the spongy bits are supposed to represent the ball of positive charge, with the plums or raisins scattered throughout it, like the negative electrons. However, at a time when scientists were discovering all sorts of new things, a scientist called Rutherford and his assistant Marsden did an experiment called the scattering experiment, and this is something you might have to describe in the exam. What they did was aimed a beam of alpha particles at a thin layer of gold foil. The gold foil was only a few atoms thick. If the plum pudding model was correct, they expected the alpha particles to travel through the thin foil without being deflected really at all. What they found was that most of the particles travelled through the thin foil as expected. However, a few other particles were deflected in lots of different directions, and this was unexpected. Some were even deflected all the way back to where they'd come from. This suggested that the plum pudding model wasn't correct, and in fact, the positive charge was not spread throughout the atom, but concentrated in a tiny area in the centre of each atom, which they called the nucleus. This discovery led to a new model of the atom, which they called the nuclear model. This model suggested that all of the positive charge of the atom was contained in a tiny sphere in the centre of the atom called the nucleus, and that the electrons were found around the outside. It didn't take long, however, for new experiments to suggest yet another model. This time, instead of all of the electrons rotating around the nucleus in the same areas, a scientist called Bohr suggested that they rotated in fixed energy levels, which we call shells, and that the electrons orbited at specific distances away from the nucleus. Later experiments realized that the positive charge was now divided up into protons rather than contained in a single central space. They found that there was as many protons as there were electrons, which means that the atom overall has a neutral charge. However, in 1932, a scientist called Chadwick found out that there were some more particles in the nucleus that we hadn't known about previously. These didn't have a charge, although they did have mass, and they called these neutrons. This is a timeline showing the key stages in the development of the atom. Here we have the original idea of the indivisible atom. Then we found the electron, and we developed the plum pudding model, which suggested that electrons were dotted throughout the atom, which was a ball of positive charge. Then we discovered, through the scattering experiments of Rutherford and Marsden, that the positive charge was actually not found throughout the atom, but was concentrated in a tiny space right at the centre of the atom. Then Bohr suggested that the electrons, instead of all rotating around the nucleus in the same place, all rotated at specific measured distances around the outside of the atom. Finally, we discovered that the positive charge in the centre was made up of protons, and that neutrons were extra particles which added to the mass of the atom, but didn't have a charge. Hopefully this video has helped you to understand how our ideas about science change over time as new discoveries are made and new evidence comes to light. Thank you for listening, and see you again soon at My GCSE Science.